All right, a second review problem here. We're going to factor, or second review video here, I'm sorry, for the quiz. We're going to factor this problem here down completely. It has 4 roots. That may involve some imaginary ones or complex ones. So to help us out here to get you started, you put it into y equals. We look at the graph, and I've identified -2 and +5 as real roots. The rest of them are probably going to be complex. So we'll start by doing a synthetic division. I'm just going to pick I'm going to pick 5 as my starting point here. So if I put 5 inside the box, and I have 1, -13, +46, 22, and -260. And let's see here, this is going to synthetically divide. That's a 260 up there. So we begin the process, multiply, add, etc. 5 times 6 is 30, makes 52, and 52 times the 5 is exactly 260, which gives us what we had hoped for, remainder of 0. So constant x, x squared, x cubed. Actually, we could just keep on going here. I know that -2 is also a factor, so I'm just going to take -2, and I'm going to divide it into this guy. So 1, -8, +6, +52. So we bring down the 1, multiply and add. And I multiply, add, and one more multiplication brings me exactly to -52, 0 remainder, what we had hoped for, reassuring us that that is a factor. Now I'm at a point where I've got x squared minus 10x plus 26. This does not factor, so to keep on going, I have to set that equal to 0, so I'm going to use quadratic formula here. The opposite of b, plus or minus the square root of b squared, that's 100, minus 4 times the a value of 1, that doesn't even matter, times the c value of 26. All of that will be divided by 2 times a, which in this case is just 2. So this is 10 plus or minus. Well, if you type in the stuff under the square root, it ends up to be -4. That's 100, and 4 times 26, yeah, that's going to be -4 over 2. Well, this becomes 10 plus or minus 2i is the square root of -4 divided by 2. So since both of these things are divisible by 2, I'll go ahead and divide them, and I get 5 plus or minus I. And so that's it. My roots, if I'm going to list them all, we'll do it in a different color here. Originally we had the 5, so that makes a root of x minus 5. We had the -2, so that makes x plus 2. Now we've got the complex roots, x minus, parentheses, 5 plus I, and x minus, parentheses, 5 minus I. That's a completely factored version of the original thing that we started out with. The one on the quiz won't be quite as nasty here with the complex numbers. It'll be a little bit simpler than that, but that is a way that we can completely factor a problem like that. I wanted to point something out earlier that I did not point out, so I'm going to do another one of these problems where we convert this into standard form and we identify the vertex. So to go through that process one more time, I meant to put f of x in front of there, but anyways, we'll take the -2 and we're going to factor it out of the x squared plus 8. So that's going to make this a minus 4x. I leave the blank spot like we did before, and -5 goes out here. If I were to distribute this back through, it would take me right back to here. So the process is I take half of this number as -2 and I square that, I get positive 4. Now, what I've really done is I've subtracted 8, because it's negative 2 times 4 is negative 8, so I balance that by doing plus 8 out here. Now the parentheses is a perfect square. That's x minus 2 squared, and out here I have plus 3. So this is standard form. The vertex should be positive 2, positive 3. Now, what I wanted to show you guys earlier, if you ever get to a problem like this and you're not sure if you did it right, I have a way for you to check. We're going to use the test option here in the calculator. The test is in the second math screen, okay? So that's where I'll be going eventually. So from the main screen, I'm going to type in my original, negative 2, I'm just going to use the x squared plus 8x, and we have minus 5. I want to see, is that equal to, so I go into that test screen, I select equals. Now I'm going to put in what I came up with down here. Negative 2, oops, I forgot, missed the negative there. Negative 2, parentheses, x minus 2 squared, so x minus 2 parentheses squared, plus 3. Okay, I put this in, and I'm seeing, is that equal to this? Is it the same thing? If it is, the calculator is going to tell me 1. That's binary code for yes. If it was not equal, like let's say, let me bring the command up again. Let me just change it so that it's not going to be equal. For instance, now it won't be, it'll tell me 0. So that's a way that you can at least tell if what you came up with is accurate. Okay? So that's that. Let's go to this third problem, using the rational zero test to list all the possible rational zeros of this function. Well, we know that the rational zeros, if there are any, are going to be in the form p over q, where p is the factor of this number. So I'm going to list the factors of negative 6. Well, that's basically plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. The denominator is going to be the factors of the lead coefficient, which is 2. So plus or minus 1, plus or minus 2. So the factors, the possible rational factors, are going to be every possible combination I could make. So I'll take the first number and I'll put 1 over 1. Well, that's plus or minus 1. Take that number over 2, so that's plus or minus 1/2. That's a plus or minus there. Sorry. Now I go on to the 2. 2 over 1 or 2 over 2. Well, that's going to be plus or minus 2. But 2 over 2 is 1. I've already got that one listed, so I'm not going to list it twice. I go on to 3. Plus or minus 3 over 1, which is plus or minus 3. Or plus or minus 3/2. And I put it over the 2. Now I go to the 6. I got plus or minus 6 over 1. Or plus or minus 6 over 2, which is 3. I've already got that one, so I won't list it. So these are all possible rational zeros. We're not asking that you necessarily find them on a problem like this, but we want you to be able to use the rational zero test to at least list them, the possible ones. Another thing that I didn't mention in class, but I don't want you to overlook it, is the complex numbers, multiplication, division. I'll do one here that's division, because I think that one really involves a lot of stuff. So let's say we have something like 3, better yet here, I got a problem here that works out nice. Let's say I give you 5 divided by 7 minus I. We know we're not supposed to have i's in the denominator, so we get rid of that by multiplying by the conjugate on top and bottom. So 7 plus I, 7 plus I. That's the number 1 written in a fancy, creative way. So now, when I multiply this out, 5 times 7, 35 plus 5i. On the bottom, 7 times 7 is 49. Now the outer product, 7i, and the inner product are going to cancel because they're conjugates. And then I have negative I times I, which is negative I squared. Well, this becomes 35 plus 5i divided by, this is, don't forget, I squared is -1, so 49 minus -1 is 50. Now, every one of these three numbers is divisible by 5, so we'll simplify it that way. Take every one of them, divide by 5. That's 7 plus 1i divided by 10. So in standard form, this is going to be the fraction 7/10. That's the real part of the complex number. Plus, now the imaginary 1 here makes it 1/10 I. That is the correct way, a standard form of this division. So you'll see that. You'll see something like that on the quiz. You will also see problems where it's just straightforward. You're going to add two complex numbers or you're going to multiply two complex numbers together. So be prepared for that and review your homework as necessary.